Okay, so hello everyone. Welcome to Coffee and Compressed Air. Today it's me here, Elvira, and welcome to our regular Coffee and Compressed Air. So, sending you greetings from Europe. Uh, Grab your cup of coffee, cup of tea, and I'm inviting you today to discuss eternal questions that we usually have in compressed air. How to calculate compressed air cost, the question that I get every second day probably, how to find the correct blow-in applications, and you find millions and millions and millions formats, pictures where it's written the 1 millimeter of leak cost this under this pressure. And honestly, as the person that hates any Excel tables, and I really like compressed air systems because they are very dynamic. Once you once you change the pressure levels, everything, the performance is changing. So we actually cannot rely on those numbers. And with the team, we thought for few months how we actually can help it. And we came up with a very, I would say, like a trivial idea. Let's do an online calculator, but let's do a full platform for the online calculators where we can give an access to the calculations of the blow-in application, flow application, pressure drops, pipe sizes, and so on and so on and so on. And let's make it a growing platform where also you can go and calculate any cost that you need. If you don't want to use more sophisticated modeling and simulation tools, diagnostic tools, and you need to calculate only one single component, you always can go to our platform. So we're starting with a very simple thing. We're starting with the three basic calculators, and now I'm going to go into the screen and show you how we can start calculating things. Well, I hope that the connection is fine. You can see me fine. And so we start first of all with the compressed air cost calculator. And here, of course, you have two uh, possibilities. So one possibility is if you have information on the power and free air delivery, or the other possibility if you know the specific power of the compressor. So you simply choose which one you want to have. You put the electricity price here. You put also the maintenance cost of you can calculate it, and maybe you have, usually it's at 12% from the total energy cost, 12 to 13% from the total energy cost, so euros per cubic meter. So the full load power, also what it is, percentage there. The free air delivery is full load power, the kilowatt hour, and free air delivery is cubic meter per minute. Change also unit as you wish. And then also the load fractions, unloads power, again in the percentages, and also intake temperatures. So by changing intake temperatures, you can see how it actually affects and the cost. As a result, you have a wonderful calculation of the energy intensity, energy cost, how many euros cost per cubic meter to produce your air in the facilities. So there some electricity consumption that exactly the same as energy intensity, some key insights that also can get there. And of course, you also can share this information with your colleagues. So here, very similar approach to the specific power. So you change also, I don't know, temperatures here. Everything is calculated here then automatically. And then you can save also runs for this and go ahead. So this is usually the information that we require to all other calculators. So meaning that whenever we calculate any system performance, let's say you want to calculate leak cost, as I said before calculating leak cost, you need to know how much cost 1 cubic meter to produce, 1 normal cubic meter to produce. Let's go to the leak calculator. Imagine that our line pressure is 7 bar. So I know it's a bit confusing. It's 6 p.m. for me here, so probably people from Europe are not watching or drinking coffee today with me. But you can also change it to the PSI and CFM here. So, but I'll use my units where I feel comfortable. So imagine that you have a line pressure of 7 bar, and you want to understand how much cost 1 millimeter of a leak. You have 2000 hours of the operations and energy cost, certain energy cost. You also have a certain plant size because you need to understand what would be an approach to the leak detection. And once you can calculate the leak impact, you can see that 1 millimeter for 7 bar cost 1300. So the for 6 bar it costs 1200 almost. This is what is how much you lose in the flow. And this is quite interesting information because of course leaks, it's a whole new picture, right? It's a whole new system. You don't have a perfect orifice of 1 millimeter, but this tool is meant to be used just to give the feeling, for example, of what if you change the pressure levels, how how it's going to affect your leak cost, right? Your leak production, your flow. So you see, if you have a 7 bar, it's 1300, and if you have 4 bar, it's 700. So this can give you an idea, even makes sense for you to reduce the pressure levels. Think about the multi-pressure system and so on. Of course, it's not a leak detection tool, it's just the understanding what are the how the sizes can also calculate, how operating hours can calculate energy cost, and so on and so on. So here the energy cost is of course compressed air cost that you calculate before. So when we once we calculate it and we do, sorry, it's here 002. So you have a certain uh, uh, suggestions that, for example, the only one leak cost will be this 200 euros. If you have 50 leaks, if you have 100 leaks, if you have 200 leaks, it can go to a very significant number. So meaning that you actually can use this tool if you are an energy manager, if you are facility operator, facility manager, you can use it to justify the leak detection, calculate the ROI for before even hiring a company that would do the leak detection audits, right, and repairing of that. So of course you need to then justify buying the tools, hiring an auditor. I mean, I've been there myself. I know it's not easy usually to convince your boss to start reducing the energy consumption, and the boss always wants to see what's going to be an investment. And here you have some ideas already for the tools that you can use. This, if you have a lot leaks, if you have low pressure and it's not significant, it's not important, then you just forget about it. But you can have here some ideas of the key components that you can find on the market. So you simply can just add it to the bill of material. We're not selling anything through this platform, but it is just like a formative platform in order for you then to connect directly to the suppliers of those components and get an offer from them. So again, it's not we're not having any preferences here. So only the companies that are in the platform. So this would be then the leak detection, leak calculator. Once you add it to your bill of material, then you can go to other applications to calculate. So as I said, we are planning to expand it more and more and more. I'm planning to have an updates every 2 weeks to have a new calculator here, or every 3 weeks, and you will be getting the updates. So don't hesitate also to send us the information, send us also the ideas, what type of calculation you would like to see, and we will integrate them. So let's now think about the blow-in application. So again, very often in the facility, a very quick win is to install a blow-in guns instead of the open pipes. And you can simply calculate inside the pipe diameters, the line pressure, also a number of operating hours, as well as your compressed air cost. So here you see it tells you that this diameter is quite small, so probably you have like a bigger one. And here you have also the information of the flow application results, how much it would be for the open pipe, uh, the blowing gun that fits this application, how much it would consume, what would be the blow-in force. And again, you need a blow-in force that is lower. So maybe you need actually the blowing gun also with the lower blow-in force. But the logic here is that you on the first step, you just see what is the open pipe of this diameter produce the blow-in force, which blow-in force it does produce under this certain pressure level. And then it looks for the blow-in gun that has also this performance. So everything comes from the performance. But of course, in the next iteration of the calculator, we add more information. So maybe you don't need, usually you actually don't need like such a high blow-in force. So it can be then adjusted. So we have here a certain key insights that also can be useful for you. So as well as the suggestion of the compatible components. Usually in the catalog you find the air guns under certain pressure levels. So here you have already recalculated with the blowing forces, with the calculator, you have the information about the environmental, especially important thing about the safety notice, right? That once you have any open diameters, once you have any open pipe, the blowing, it will violate also the blowing force safety standards. So here you see the noise reduction that is actually then compliant to the standard once you do it. So after you decide to choose one of the components, you can go to the website and check also more information there. Here you just have an essential information. You can go directly ask supplier for offer for you, so you can actually calculate an error or return on investment on that. So you add to the bill of material, and then now you have a wonderful mini BOM. We call it mini bill of material, meaning that from each single calculator you can calculate separately components and add it to the BOM and see the ROI. So once again, I'll remind you that it's extremely important to calculate also and analyze the complex system in the software, for example, such an EasyCAS, when the components are installed there and go like into the lines, because they will have the pressure drops and they will have the certain performance, because it is a compressed air system. It's not that compressor works only for one component. Sometimes by replacing only one component, you will not see the changes. Sometimes you even can have you need to go into the more details and calculate more and more and more in order to have the maximum performance of the entire system. But this is a very good start. If you already have the misuse of compressed air, if you're thinking to start with the leak analysis there, if you don't know how to calculate what is your compressed air cost now per cubic meter, you don't have a certain levels, you don't have the monitoring systems, for example, this is just a good start, because you will see that going into the optimization and reduction of compressed air, it's such a low-hanging fruit. Really, there are so many opportunities, and please don't be afraid of this, because it is ROIs below 1 year for entire systems. It's a very, very common cases, and for some upgrades of the system below 6 months, 2 months, and so on. So it's really too good to be true. So you can then contact the supplier. So just fill up the form in order to get an offer for you. And also you can download the BOM. You have the CCV file that you can work with, check with the procurement and so on, and save runs. So this is our short presentation of what we've been doing. We will be very happy to give you to check this tool. So please also let us know if you want to see new calculations there. So we'll be coming the pressure drop calculator, the dryers, the filters, the tank sizing. So all of this cylinders, of course, cylinders applications quite complex. Nozzles, cooling, all application of compressed air. So you will find it here, and we are very keen to receive your feedback and see how it goes. And please let us know if you want to see something more, some new calculations, and it will be integrated there. So this is in a nutshell what we are doing. And if you have any comments, any questions, and any ideas, please let us know. And we will be then in touch. Comment here below this post, please, what type of calculators you want to see, what type of components you want to see, and then yeah, we will be going full development on that.
Perfect. So I wasn't supposed to be on here, but I'm hopping in. Um, just because we have the blowing gun application out still, it's my first time really digging into this. So I feel like I'm kind of one of the people viewing this right now. So it's very cool. But I wanted to add, when I was working with blowguns for 10 years, a lot of people don't actually know what the blowing force is or what that means. And so a quick trick to figure that out. So if you're at the plant, I would actually I ordered off of Amazon a small food scale, and you can actually blow the gun on there and find out how many pounds of blow force your gun has. And if you don't know what your gun requires, you can also change the PSI and then see where it works, like what the threshold is for where it works at your application. And then you could go ahead and plug that in here and get immense savings. So I just wanted to add that. If you scroll on my LinkedIn, I think maybe for 6 months or a year, you'll see a lot of posts of me doing that kind of thing because it is a little abstract, the blowing force that your gun's actually getting at the plant level. And of course, we always want to make sure that it works because that's the most important thing. Because if it doesn't work, the energy savings don't really matter. It's going to get taken off and undone by somebody if it doesn't work.
That's true. That's true. That's a really amazing trick, Danny. So it's very cool. I remember you told me about this. What I usually do when I would do like the walkthrough of the factory, and
Mhm.
sometimes it's very confusing that people say, "Ah, what is the like the open pipe?" It doesn't make sense to choose it according to the blowing force. It actually does, because when I speak to I always comment, I talk to the operator, right? And I was like,
Mhm.
how is like your application? And so many times I saw that they cut off in new installations simply because, and they say it's not blowing enough. It's not blowing enough. And then you have for the blowing gun, and we also have this video on our YouTube. I think we can then put it in the comments there.
Yeah.
You either need the high blowing force or you need the high volume, and it's like an either or, and you need to go first like to understand what is the correct application for this. So
Mhm.
sometimes when they say like it's not blowing enough, it's not maybe the force, but it's maybe volume, or it's maybe actually the force. And in this case, what we're gonna add to this calculator, we just can say, okay, what you need the force or you need like the volume. And then you can already see the calculation. And I think we were gonna add also your tips there, because it's really really nice to add it here. Yeah, so it's
Yes.
just simple tricks to start with. And if anyone like has also questions,
Yeah, we have a couple comments. I think we have about a minute left.
okay, welcome.
Let's see.
Purity class that can allow folks to see in one pack their purity class alongside the flow applications calculator. Would think that encourage air quality while thinking of leaks efficiency just a thought. I think it's super interesting. Definitely. So the quality, I'm not an expert on air quality, but we definitely can collaborate with someone to give us also insight and suggestions, and we'll be happy to integrate the calculations. I think it would be really really useful. I totally agree on that.
Perfect. That gets us at the 20 minutes. Thank you, everyone who joined, and you know how to get a hold of us for any questions, comments. Feel free to DM us. And I think we will put the link for these calculators in the comments. Yes, maybe?
Yeah. So
Okay.
Flavia also wrote blowguns trick for testing.
Oh,
Did you
yeah.
answer that question? Yes, they are.
Yes.
But
Yes, I did that so often at every plant. And one of the main reasons I did it was because I was trying to reduce noise even. And a lot of the misconception would be you're reducing the noise, so that means it's not blowing as hard. So it was a really big misconception with the operators even. So I would actually show them that test and say, look, just because the sound level is significantly lower with an engineered nozzle doesn't mean you're losing blow force. And then that was like the emoji would like blow their mind, that they're like, oh, wow, it is quieter, but it's blowing harder. Let's see, we have another one.
yeah, I agree. And the thing is that it's extremely important while you choose it to see what is the pressure level also at your plant and what is the pressure level in the catalog once you're choosing. This is, I think, that the
Mhm.
tools can be sometimes useful. So because once you change it, very often I see that the companies buy something, but I mean, you told me the same, right? They buy like micro nozzles and then it doesn't work. Of course, it doesn't work. So you need to
Yeah.
find it for your application. So and also like test it, but definitely once you have the good components and like you can find here also from the
Mhm.
catalog here you just say okay this is my requirement so I tested it and then the
Mhm.
suppliers also can give you tips so don't hesitate to talk with the professionals actually that solve your problem they're not trying to sell you the components that
Mhm.
solving your problem so but here is just a good way to start for different applications yeah.
Perfect. Thank you. I think we will end it at that, so we won't go over too much time, but make sure you're following both Elvira and my page, of course, so you get the notifications when we're going live. And on the Direktin LinkedIn site, make sure you follow that because we'll be announcing there the new calculators that are coming, different ways to use them, and more practical compressed air advice. And of course, here we'll be inviting some new people to bring even more insights to help tackle the whole compressed air system efficiently and effectively.
Yes, yes, and we're really open to collaboration. So if you
Mhm.
have again any ideas about the air qualities or things like that we don't cover, just DM us and we'll be happy to create something cool.
Perfect. All right.
Okay.
Thank you. Everyone enjoy your mornings, afternoons, and nights.
Yes, bye. Have a nice day. Bye
Bye.
everyone.